Hello and welcome to this video, which is designed to walk through the process for assigning formal charge to atoms in Lewis structures. I plan to do 3 examples, NH3 ammonia, NH4 plus the ammonium cation, and CN minus the cyanide anion. And hopefully this will be helpful. So the process that we're going to go through for each of these is we're first going to draw a Lewis structure. We have to have a Lewis structure to be able to assign formal charges to the atoms within it. And then for each atom in the Lewis structure, we need to first determine the valence number of that atom from the periodic table, and then determine the number of bonds plus the number of non-bonded valence electrons of that atom has in the Lewis structure. Finally, we subtract value 3 from value 2, and that gives us formal charge. And so really the key here is we need to do 2 and 3, and then we need to subtract those numbers. And what we're looking for is to answer the question of, is there a discrepancy between valence number and the number of bonds plus number of non-bonded valence electrons? If there is a discrepancy, if there's a mismatch between those values, then we have formal charge. Okay, let me show you what I mean. Let's start with ammonia, NH3. I invite you to pause here and draw the Lewis structure for yourself from scratch, just to convince yourself that you can do it. I'll pause for 2 seconds. Cool. And so with all these, when I say pause, you can pause it and do your thing. But the Lewis structure of ammonia looks like this. There's a lone pair of nitrogen, and there's 3 hydrogens attached. All right, so we have done number 1. Step 2, for each atom, determine the valence number. And so I'm going to actually put down I'm just going to write the atoms down. Say, okay, for each atom in this Lewis structure, I need to determine the valence number from the periodic table. So the valence number is the number that tells us how many valence electrons that atom has when it's a standalone atom. And so, for example, nitrogen up here has a valence number of 5 because it has 2s2 valence electrons and 3 2p electrons, and so it has a valence number of 5. Hydrogen has a valence number of 1 because it just has the 1s1 electron, and so each of these it's 1. Right. That is what it means to determine the valence number. It's basically saying how many valence electrons does a neutral boring standalone atom of that element have. We then can move to number 3. Number 3 says, determine for each atom the number of bonds plus number of non-bonded valence electrons in the Lewis structure. So for nitrogen here, putting a little asterisk just to note that I'm looking at the nitrogen, that nitrogen has 3 bonds to each hydrogen, right? So there's 3 bonds plus 2 unbonded electrons. And so I'm just going to label 1, 2, 3 bonds. And then this electron is number 4, and that electron is number 5. Each single electron counts as a non-bonded valence electron. And so that 5 comes from 3 bonds plus 2 non-bonded valence electrons. All right, for hydrogen, each hydrogen has 0 valence electrons around it, non-bonded electrons around it, but it has 1 bond. And so each hydrogen has 1. And I'll just write that 1 time to say, all right, each of these hydrogens has a sum of 1. And I'm just going to write this down. Number of bonds plus non-bonded valence electrons. All right, we have now done numbers 2 and 3, and we are ready for the 4th and final step, which I'll use orange for. We'll see how that looks. Oh, that looks adequate. In step 4, we subtract value 3 from value 2. 5 minus 5 is 0, 1 minus 1 is 0, 1 minus 1 is 0, 1 minus 1 is 0. Okay. The punchline here is that for ammonia, there is no formal charge at any atom. And that's why when we first started drawing Lewis structures in class using neutral molecules, you probably didn't even think to worry about formal charge. All right, let's move on to an example that has a charge, the NH4 plus, the ammonium cation. And we'll see how this works out differently. I'm actually going to use roughly the same color scheme, I think. So here we are with NH4 plus. Again, I invite you to pause for a moment and try to draw the Lewis structure for yourself. Righto, so I will now draw the Lewis structure, which puts N as the central atom and has 4 bonds to hydrogen. I think there's already a question here of like, if we have NH4 plus, this tells us, that we have a positively charged species, we have an ion, and the question we might ask is like, well, where is that positive charge? Which atom is it on? Formal charge sort of calculations will tell us which atom it's on. And so I'm going to do this exact same setup where we're going to look for, we're going to assign the valence number to each atom. The hydrogens are actually completely unchanged from before. There is still 1 bond at each hydrogen and no additional, there is still, I just messed up. What I meant to say is valence number we look up in the periodic table, so there is no change from NH3, right? The nitrogen in NH3 and the nitrogen in NH4 plus is just nitrogen. We go to the periodic table, we look up the valence number, we say, nitrogen is 5 and hydrogens are 1. It's when we go to step 3, when we go to add up the number of bonds plus non-bonded electrons, that we see some changes between NH3 and NH4 plus. All right, I'm now writing this as number of bonds plus number of free electrons plus number of non-bonded electrons. Each hydrogen is the same. Each hydrogen still has 1 bond and no non-bonded electrons. So those are kind of boring. But the nitrogen is now changed. Instead of having 3 bonds and 2 non-bonded electrons, there are instead 4 bonds plus 0 non-bonded electrons. And so this value is now 4. When I go to subtract these, right, when I subtract row 3 from row 2, I get plus 1, 0, 0, and 0. And the key is that this plus 1 says nitrogen has a plus 1 formal charge. And the way we denote that on our Lewis structure is we put a positive sign next to the atom that has the formal charge. So nitrogen is positively charged. The positive charge in the NH4 plus cation is actually at nitrogen. That's kind of how we use this information. All right, moving on to cyanide, the Cn minus anion. And I'll go to a new page because why not? Cn minus anion. Again, I will pause. I invite you to draw Lewis structure for yourself. All right, so I will now draw the Lewis structure, the Cn minus anion. The way we construct this in order to fulfill octets at both octet atoms, at both carbon and nitrogen, is to put a triple bond between them with a lone pair at carbon and a lone pair at nitrogen. We have this question once again of wherefore the minus charge, right? Where is that minus actually located? That's the question that a formal charge analysis can answer. And so let's begin to do this. So now, instead of having N's and H's, we have N's and C's. And so first thing we're going to do is put in the valence number. We have done nitrogen a bunch of times already. It has a valence number of 5. I'm going to scroll up real quick to look up the valence number of carbon. So carbon up here on the periodic table. Here we are. This has the 2s2 to p2 configuration, valence configuration. And so that has 4 valence electrons. So there we are. Next, switch colors. And we are going to sum up the number of bonds plus the number of free electrons, or the number of non-bonded electrons. For the nitrogen atom, there are 3 bonds plus 2 non-bonded electrons, which gets me to 5. Right, so just to be clear, that's 1, 2, 3, 4, 5. That's how we count it. Each electron in the lone pair counts as a free electron. For carbon, the analysis is identical. There are 3 bonds plus 2 free electrons, and I also get to 5. When I go to do my subtraction, 5 minus 5 is 0, but 4 minus 5 is -1. And what this says is that the carbon atom has a -1 formal charge. And there's a negative, therefore, at the carbon in this Lewis structure. I hope this is helpful for clarifying how to assign formal charge in Lewis structures and sort of demonstrating how we can use it to decide where a charge is located, at which atom a charge is located, or which atom bears the charge in structures that are charged. A last cautionary note: there are neutral species out there, neutral molecules, where atoms have formal charge. So you do need to be wary of formal charge at all times. And I'm sure you'll get to see that in your lectures. All right.